still there are only 42 students, so I think we should wait so that other can join the class.
Sir, लास्ट लेक्चर के मतलब क्वेश्चन था आपसे।
जी जी बेटा।
सर हमने लास्ट लेक्चर में जितना भी करंट फ्लो पढ़ा है सारा इलेक्ट्रॉनिक करंट के लिए है ना, इलेक्ट्रॉनिक चार्जेस यानी कि जो
नहीं नॉर्मली व्हेन आई वाज डिस्कसिंग अर्लियर, जब आप डिस्कस कर रहे थे हम लोग, सो वी वर टॉकिंग अबाउट द पॉजिटिव चार्जेस। नॉर्मली व्हेन वी डील विद द चार्जेस, ठीक है, करंट की जब भी बात करते हैं वी यूजुअली डील विद द पॉजिटिव चार्जेस बिकॉज एट द अर्ली स्टेजेस, ठीक है, क्या था कि इट वाज thought that charges basically flow, positive charges basically flow. Later on the discovery of the electron, it came to knowledge that in conductors the actual movement is of the electrons. So since we both show the same behavior except due to except their direction, so normally we deal with the positive charges when we talk about the current. But here specifically they have given us two figures. Now here you can see that they have given us two figures there, one with the negative charge and one with the positive charge. In actual case, the movement of the charges in the conductor takes place due to the electrons. But normally क्या होता है कि हम जब भी कोई भी phenomena discuss करते हैं with respect to the current, we talk about the positive charges. Both have the same behavior, so that's why we don't make so much fuss about it. ठीक है, so this is the reason behind it. बात समझ में आई बेटा कोई?
यस सर। सर बस मेरी ये कंफ्यूजन है कि देखें कि अगर हम पॉजिटिव चार्ज लेते हैं तो फिर हमारे पास डायरेक्शन टोटली डिफरेंट हो जाती है और नेगेटिव।
Let's suppose here बेटा in this scenario, in this figure, ठीक है, just hold on a second. ये एक सेकंड में आपको बताता हूँ. This is the direction of the positive charges here. Okay, let's suppose in the downward direction. What would be the force acting on it? Obviously, it would be in the right direction. ठीक है, यही होगा ना बेटा?
Yes sir.
ठीक है, जो आपकी डायरेक्शन होगी फोर्स की इनटू द पेपर अगर आप करते हैं, वेलोसिटी आप ले रहे हैं, ठीक है, तो फॉर द पॉजिटिव चार्जेस क्या होगी, इट वुड बी इन दिस डायरेक्शन. फॉर द नेगेटिव चार्जेस क्या होगी, इसके अपोजिट हो जाएगी. सो दिस इज द ओनली डिफरेंस बेटा. ठीक है, सेम बिहेवियर, ओवरऑल सेम बिहेवियर है. मतलब आप नॉर्मली जब बात करते हैं घर के अंदर भी, यू टेक वन लाइव और वन जो है आप न्यूट्रल लेते हैं. ठीक है, लाइव यू यूजुअली टेक इट एज पॉजिटिव, बट इन एक्चुअल केस देयर आर इलेक्ट्रॉन्स दैट आर क्रिएटिंग द मूवमेंट देयर. ठीक है, लेकिन हम उसको पॉजिटिव इसलिए लेते हैं, कन्वेंशनल करंट के पॉइंट ऑफ व्यू से वो हायर पोटेंशियल हो जाएगा, ये जीरो पे है, तो अगर जीरो को हम नेगेटिव ले लेते हैं, जो आपका पॉजिटिव है, जो बेसिकली इलेक्ट्रॉन जहाँ पे ज्यादा है वहाँ पे हम लोग पॉजिटिव ले लेते हैं बेटा. सो दिस इज द रीजन बिहाइंड इट. बिहेवियर सेम है, इसलिए उसको बिहेवियर इन दैट सेंस हम बात करें कि अगर इलेक्ट्रॉन की बात करेंगे, ठीक है, तो इलेक्ट्रॉन भी क्या कर रहा होगा. अब यहाँ पे इस सिनेरियो के अंदर पॉजिटिव चार्जेस आर गोइंग इन द डाउनवर्ड डायरेक्शन. अगर इलेक्ट्रॉन इन द डाउनवर्ड डायरेक्शन होते तो क्या होना था, अगेन फोर्स वुड बी इन दिस डायरेक्शन ऑन द नेगेटिव चार्जेस. आप समझे? एक सेकंड ये मुझे दीजिएगा, मैं आपको बताता हूँ. For the positive charges, force would be in this direction, right direction. ठीक है, यही होगा in the right direction. And if we are taking the negative charges, तो क्या होगा, force would be, हम लोग क्या कहते हैं जी, उसके opposite हो जाएगा. तो again इलेक्ट्रिक फील्ड तो इसी तरह सेट होगी ना, for positive to negative. तो बिहेवियर तो एक किस्म का सेम आ गया कि इलेक्ट्रिक फील्ड was actually setting positive here and negative here. In both cases they are setting here.
Yes sir.
आपको समझ में आई बेटा?
जी सर, थैंक यू वेरी मच सर.
ठीक है, ओके. सो दिस इज द रीजन बिहाइंड इट. अनटिल लेस के आप डायरेक्शन चेंज कर रहे हो उसकी मूवमेंट की, देन देयर इज अ डिफरेंट स्टोरी. ठीक है, जब आप डायरेक्शन चेंज करते हैं No, here is a negative which is moving in the upward direction, and here it is a positive which is moving in the downward direction. Then story is different. But again, the strength of both electric field would be same. In actual case, positive तो क्या होना चाहिए? अब ये मैं समझाने की तो मैंने आपको समझा दिया, आपको समझ में आ गई, बात क्लियर होगी. लेकिन एक्चुअल सिनेरियो के अंदर क्या होगा कि अगर if you are talking about the current due to the positive charges, the movement should be in the downward direction for the positive charges, and for the negative charges, the electrons should move in the upward direction. ठीक हो गया? In both cases, अब क्या हो रहा है कि आपकी इलेक्ट्रिक फील्ड की डायरेक्शन जो है that is getting changed here. ठीक है? In one case it is in this direction, and in one case it is in this direction, but the strength of both electric field is same. The only sense is that the direction is changing. So when we talk about the electronic current, we specifically call it as we are talking about the electronic current. Okay? Then obviously let's suppose if there is a teacher who is checking your exam, it obviously clear to him that direction would be opposite to that of the positive direction. Okay? The strength of both electric field will be same. It will not change. Okay?
Yes sir.
अच्छा, अब जो चीज जरूरी है, मतलब when you are discussing or you are writing an article about the Hall effect, then you have to clearly mention whether you are taking, if you are generally saying about the current, okay, it is mostly we will deal with the conventional current. But if you are taking the electrons in the figure, then you have to mention it that you are talking about the electronic current. Then we are clear, okay, the teacher will become clear, okay, the direction of the force would be in this direction. But if you are just writing current, so it means we are taking the conventional current, and then if you are giving the direction of due to the electrons, we will consider, we will negate it, because in actual case it should be like for the positive current. Okay?
Yes sir.
Okay. So any other question about the last article, बेटा? ओके बेटा, आज थोड़ा सा लेक्चर जो है मैं जल्दी करवाऊंगा, ठीक है? और उसमें ये है कि देयर इज अ फाइनल प्रेजेंटेशन ऑफ माय एमफिल स्टूडेंट्स. So right after this lecture, there is a final presentation. So we will start right about the. We will now start the lecture. I don't know why students are, and there are only 54 students, and yesterday there were about 66 students. So the actual strength is about 74 students. So why there are so many students missing today? क्यों भी हसीब?
सर पता नहीं, नेटवर्क वगैरह इशू होता है या बिजली नहीं होती.
चले, okay, so again this is the article which we already have, which you already have studied in FSC, a circulating charge particle. So there are a couple of phenomena that we will discuss here, like when the charge particle will move in the circle, and when the charge particles move in the helical path with the circular radius smaller and with the circular radius larger. So we will discuss both these things in this article. ठीक है? So when we do know that when a charge particle moves within the magnetic field, it moves into the circular path. And why is it so? क्यों circular path में move करता है? क्या कहते हैं आप?
Centripetal force.
Centripetal force.
Velocity
From
perpendicular तो वो circle.
So okay, ठीक है बेटा. Why they are getting the centripetal force? Because deflection will be, or the magnetic force will always be perpendicular. So then why they are moving in the circular path?
सर क्योंकि जो फोर्स है वो उसका मैग्नीट्यूड नहीं चेंज कर सकती, वो उसकी सिर्फ डायरेक्शन चेंज करती है.
Okay, it is changing the direction. Okay, let's suppose a particle is moving in the straight direction. So the force will be in the upward direction. So the particle should move in the upward direction rather than in the circular path. क्यों? It should move in the upward path rather than in circular. So why it is moving, why it moves in the circular path?
सर क्योंकि वो बाउंड किया होता है.
नहीं, we never bound any particle. We will never bound any particle unless there is a specific reason.
सर मैग्नेटिक फील्ड का इफेक्ट होता है शायद.
Obviously बेटा, there is a magnetic field effect. ठीक है, एक सेकंड, जस्ट होल्ड ऑन ए सेकंड, मैं आपको यहाँ पे एक्सप्लेन करना चाहता हूँ. ठीक है, एक तो आप ये सपोज करें कि मैग्नेटिक फील्ड जो है दैट इज इनटू द पेपर. ठीक है, लाइक इट इज इनटू द पेपर. ठीक है, एंड ए चार्ज पार्टिकल इज मूविंग with some velocity v in this direction. एक सेकंड, in the right direction. Okay, so what would be the direction of the force for the positive charge particle?
Upward.
Upward. So how it will move in the circular path if it is in the upward direction? This is what my question is. आप लोग सारे बड़े लायक बच्चे हैं, ठीक है, मुझे पता है, लेकिन इसका आंसर एक छोटा सा कंसेप्ट है, इसका आंसर तुम मुझे दे दें.
सर क्वेश्चन क्या है?
क्वेश्चन ये है कि दिस पार्टिकल इज मूविंग थ्रू द मैग्नेटिक फील्ड, so what would be the direction of the magnetic force? Obviously it would be in the upward direction. ठीक है, पॉजिटिव चार्ज पार्टिकल है, राइट हैंड पाम रूल लगा रहे हैं, so the magnetic force would be in the upper direction, so obviously particle will move in the upper direction. So the question is which you already have studied in FSC that when a charge particle moves within the magnetic field, it moves in the circular path. So how it is able to move into the circular path when the deflection is in the upper direction?
तो जब वो ऊपर जाएगा उस पर दोबारा फोर्स लगेगी.
Yes, this is the reason.
फिर उस पर दोबारा फोर्स लगेगी.
This is the reason, beta. At each and every point, beta. At each and every point, the force on the particle will be perpendicular. So let's suppose the particle move, the charge particle moved in the upper direction. Okay. The force at this point, in the upper direction. Let's suppose here in the upper direction. Okay. Then when it will reach here, okay, now the direction has changed. Direction of the particle has changed. Now the velocity segment is in the upper direction. So at this point, again, a perpendicular force will act on it. Okay, at each and every point. So it will be perpendicular. It would be something like that one. Okay, then again, after reaching at this point, again there will be a force. Now the particle has reached here. Now the direction of the velocity, again the direction of the particle has changed. So is the direction of the magnetic force. So obviously at this point, again a force that will perpendicular, which in this case is tangent to the direction of the particle. Now the particle will reach in the bottom point at this point. Now again the velocity, direction of the velocity changed. Okay, again at this point, again a perpendicular magnetic force will act on it, and in this way the particle will move in the circular path. Is it clear, beta?
जी सर.
नो सर.
हसीब को समझ में नहीं आई?
नहीं आई सर.
अब मैं मैग्नेटिक फील्ड ड्रॉ नहीं कर रहा. मैग्नेटिक फील्ड इज अज्यूम दैट इट इज इनटू द पेपर. ठीक है, सो दिस इज a charge particle, positive charge particle. ठीक है, it is moving in this direction. ठीक है, it is moving in this direction. ठीक है, what would be the direction of the magnetic force? Obviously it is in the upper direction. ठीक है, so particle will move up to this end. ठीक है, No particle is moving in the upper direction at this point. Let's suppose. ठीक है, मैं सिंपल कर रहा हूँ आपके लिए. Particle reached at this point. Now, what is the direction of the particle or the velocity of the particle? In which direction it is?
Upward.
Upward है. क्योंकि ये सीप upward ही है ना?
जी सर.
Okay, so it is in the upward direction. Now, what would be the direction of the force here? Magnetic force. It is in the left side. Right
लेफ्ट वाली साइड पे होगी सर.
ठीक है. Okay. So the force would be, एक second. Force would be in the left direction. The particle will move here up to this point. So now what is the direction of the force here? No, particle is moving in the left direction right now.
Downward.
Okay. Downward. Okay. So the particle will move, come by here. ठीक है. Now the direction of the force is, what would be the direction of the force?
Downward.
No.
फोर्स की बात कर रहे हैं सर. राइट साइड.
Right side पे. So again it comes to this point. So it means that particle is moving in the circular path. It started from here, it came back to its original position, moving in the circular path. Each and every point in between the, like here, at each and every point, the particle experienced a perpendicular force that forced it to move into the circular path. हाँ जी असीम, अब क्लियर हुए बात?
ठीक हो गया सर. जी सर.
चले.
एक्सक्यूज मी सर.
जी जी बेटा.
सर हम इधर ये कह सकते हैं कि ये जो मैग्नेटिक फील्ड है ये पार्टिकल को सेंट्रीपिटल फोर्स प्रोवाइड कर रही है जो उसको एक सर्कल में मूव करो.
Obviously this QVB will be equal to this mv square over r. Later on we will discuss about this one. ठीक है. So abhi just I am just giving you the basic concept that how a particle moves into the circular path. The thing which you are saying is correct one. ठीक है. लेकिन हम लोग ये कि इसी को हम आगे एक्सप्लेन मैथमेटिकली हम लोग एक्सप्लेन करेंगे. ठीक है बेटा, in the next part of the article. ठीक हो गया?
यस सर.
Okay, fine. So अब what he is saying कि उसने एक एग्जांपल दी है. कहता है कि जो है, एक सेकेंड बेटा. No, this is the example of a electrons. ठीक है. Electrons को we move the electrons in a gas chamber. ठीक है. Low pressure gas chamber. ठीक है. And their path is flowing here. Circular path is flowing here बेटा. So this is the circular path. So this charge particle जो है which is negative in this scenario, ठीक है, is moving. ठीक है. And आपके पास क्या है कि perpendicular magnetic field है that is acting to the chamber, glass chamber, perpendicular magnetic field, and the direction of the magnetic force is given by. So the charge particle will move into the circular path. So मैं थोड़ा सा परेशान हूँ बेटा कि is he giving the right direction or is he giving the wrong direction? This direction of magnetic force is okay कि ये गलत आ रही है by right hand palm rule?
सर अगर आप परेशान हैं तो मतलब गलत आ रही है.
नहीं यार, बुक वाला तो ठीक होगा. मैं तो वैसे भी परेशान हो ही जाता हूँ. जब आपके गंदे पेपर देखूंगा तब भी मैंने परेशान हो जाना है. क्या कहते हैं कि अच्छे पेपर देखूंगा?
इंशाल्लाह सर अच्छे पेपर देखेंगे.
चलें, गुड बेटा. Obviously it is basically he is talking about the electron. ठीक है. So magnetic field is coming out of the paper in this case. ठीक है. It is not into the paper, it is out of the paper. So the direction of the fingers would be in your face. ठीक है. While the direction of the palm will be in the upward direction. ठीक है. एक सेकेंड बेटा, एक सेकेंड होल्ड कीजिएगा। Okay. So I was saying the direction of the fingers will be pointed toward you, while thumb will be in the direction of the velocity. Okay, so it means that the palm will be in the upward direction, while upward direction will shows the magnetic force for the positive charges. And since we are talking about the electron, so it will be in the magnetic force will be in the downward direction. So I think you got it. ठीक है, आप जरा ट्राई करें by picturing this figure or using the right hand palm rule. कि मैं ठीक कह रहा हूँ या गलत कह रहा हूँ? किसी को कोई प्रॉब्लम हो अप टू दिस पॉइंट?
सर हर सर्टेन पोजीशन में उसकी वो चेंज हो रही है ना, तो बस यही इसी वजह से वो सर्कुलर पाथ में मूव हो रहा है। ठीक है बेटा, सो जस्ट ऑलवेज रिमेंबर दिस वन। सो नाउ वी विल डिस्कस अबाउट द
सर रिपीट करते हैं,
रिपीट कर दूं। Magnetic field is in the out of the magnetic field is out of the paper. So fingers basically we point out the fingers in the direction of the magnetic field. So the fingers will be in the direction of your face. Palm will be in the upward direction. Thumb will be in the direction of the velocity. So obviously the direction of the magnetic force will be in the downward direction because we are talking about the electron. Now it is clear to you, beta?
Yes, sir.
Okay, fine, beta. Acha. Now here, a student asked about okay, this force will act as a centripetal force. Obviously, he was saying right that this force will act as a centripetal force. So centripetal force is basically equal to mv square over r. Okay. So क्या होता है कि this is the centripetal force that keeps the body into the circular path. So here in this scenario, the centripetal force QVB is the centripetal force that is forcing the electrons to move into the circular path. Okay, so these two relations are given by, so F here in this case is QVB. So QVB will be equal to mv square over r. Okay. From here we determine the radius of the circle. So the radius of the circle would be equal to this relation. It is dependent on the mass of the charged particle, its velocity. It means that greater is the velocity, greater would be the radius, and it means that greater would be the magnetic field, smaller would be the radius. Okay, this relation tells me this one. Okay. This is the charge here, magnitude of the charge, which would be equal to obviously 1.6 × 10⁻⁻19. So here you can see that on two things that is directly proportional to the radius are mass and velocity. Greater is the mass, greater would be the radius. It is common, it is logical to assume that if you are circling the heavy stone with a string, so heavy stone obviously will you need more force to keep the circle small in order to circulate the heavier body into a smaller radius. Okay, so again the greater is the radius, obviously again you need larger force to keep the radius small. And again if you are using the एक सेकेंड बेटा, इसको मैं प्रॉपरली आपको एक्सप्लेन करता हूँ.
सर ऐसा भी कह सकते हैं ना कि जैसे अगर गाड़ी राउंड अबाउट में क्रॉस करी, अगर उसकी वेलोसिटी या स्पीड ज्यादा हो तो वो इनर वाले साइड पे ज्यादा रहेगी, अगर कम होगी तो अब बाहर में भी जा सकती है।
इसी तरह बेटा, सो हेयर ये देखें आपके पास we have two bodies here, ठीक है, one has a larger radius and other has a, sorry, one is the heavy one, other one is the lighter one. So you need lesser force to keep the body to move into the circular path. And if you are using the heavier body, obviously you need larger force to revolve the body into the same radius, with the same radius, ठीक है. So in this scenario, this equation tells me that if you are the radius of this charged particle here in this case is dependent upon its mass directly, means that larger is the mass, larger would be the radius. If you are keeping the other quantities constant, if you like velocity, charge and magnetic field, if you are keeping them constant, and if you have a heavier mass, so you have two particles, one with heavier mass, other with the lighter mass. So the radius would be larger for the heavier mass. Again, if you are keeping the mass constant, magnetic field constant, charge constant, and if you have two charged particles with different velocities, one has larger velocity and the second one has the smaller velocity, so it means that the radius of the larger velocity particles will be larger compared to the particle which has the smaller velocity, and same is the case with the magnetic field. Now it is clear to you, beta? Should I repeat it?
नहीं सर, क्लियर है।
Okay. अब आ जाते हैं toward the time period. Okay, the time period, how we can calculate the time period? ठीक है, टाइम पीरियड क्या होता है आपके पास? ऑब्वियसली किसको कहते हैं आप टाइम पीरियड? द टाइम रिक्वायर्ड टू कंप्लीट द वन कंप्लीट रेवोल्यूशन, ठीक है. अब यहाँ पे व्हाट इज द कंप्लीट रेवोल्यूशन?
पूरा सर्कल
2 by r।
पूरा सर्कल, obviously 2 pi r, circumference of a circle, so which is given by 2 pi r divided by the velocity, ठीक है. We can put the value of the v, from where we can put the value of the v? हम v की वैल्यू पुट करेंगे r की वैल्यू, we are putting the value of the r here, ठीक है. So r v की भी पुट कर सकते हैं and result would be the same one. So from this equation 2816 you will put the value of the r, which is equal to mv over qb, and then the final relation will be equal to this one, 2 pi m over qb. So this is the time period or the period required by the charged particle to complete a one revolution. Again, we can see is the inverse of the time period. So 1 by t, we will take just the inverse, and then the angular frequency is equal to 2 pi f, ठीक है, which is equal to qb over m, ठीक है. So these are the things that we have studied today, and from these last three relations you can see that the time period frequency and the angular frequency does not depend upon the speed of the particle, provided condition क्या है कि it should not be comparable to that of the speed of the light, ठीक है. And fast particles will move in the large circle and the slow ones in the small circle, ठीक हो गया. तो ये चीज हम लोग प्रीवियसली डिस्कस कर रहे थे. अप टू दिस पॉइंट एनी क्वेश्चन? किसी का कोई क्वेश्चन हो अप टू दिस पॉइंट?
सर एक
ये आपने
थोड़ा सा
वेलोसिटी वाली क्या बात की है?
वेलोसिटी वाली ये बात की है कि this time period you can see here that equation 28, 17, 18 and 19, these are not dependent upon the velocity here. यहाँ पे ये velocity पे dependent नहीं है, ये बात की है बेटा. as per equation ये velocity पे dependent नहीं है, ना time period, ना frequency and ना ही angular frequency. कहीं पे आपको वी नजर आ रहा है बेटा?
नो सर, सर ओके ओके
सर जी क्लियर है।
ओके
यस सर।
ठीक है, अब आते हैं टुवर्ड द नेक्स्ट हेलिकल पास। आई थिंक टाइम पीरियड एंड होने वाला है बेटा, आप क्लास रीज्वाइन कर लें। 2 बजे क्लास तो नहीं है आपकी?
यस सर, पाक स्टडीज की क्लास।
अच्छा यार, मुझे कोई फ्री टाइम नहीं देते वैसे आप?
सर मंडे वाले दिन ले,
मंडे को मैं बिजी हूँ यार।
अगर बिलाल को कोई एतराज ना हो सर तो ले लें।
नहीं, मंडे को बेटा मैं बिजी हूँ, क्योंकि मेरी एक डिपार्टमेंटल पोस्ट ग्रेजुएट रिसर्च कमेटी है, उसकी मीटिंग है। वो एजेंडा वगैरह मैंने ही तैयार करना, कोऑर्डिनेटर हूँ उसका।
बंदा बन जाए यार।
तो चलें देख लेते हैं। ठीक है, अभी आप बेटा दोबारा रिज्वाइन कर, ठीक है?
ओके सर।
देन आई विल डिस्कस द नेक्स्ट आर्टिकल।